module, which is chapter H, which is entirely about permutation, combination, and probability. So in this particular part, the first topic H1 is basically fundamental principle of counting. So let's explore what are we going to study here. The first part will be obviously some ideas related to fundamental principle of counting, and the second part will be introduction to linear arrangement with respect to permutation and combination. So let's start with this. So what do we have in front of us is we have four cities A, B, C, D connected via different roads. For example, city A and B are connected via four roads H, I, J, K. Cities B and C are connected via three roads which are P, Q, R, and cities C and D are connected via five roads which are V, W, X, Y, Z. And now based on this, we have some questions to tackle. The first one, number of ways of going from A to C. Now the best part about permutation combination is that each of the question can be solved with two approaches. One is the AND approach and one is the OR approach. So whichever is convenient to you, you can go ahead with that. Some questions will favor AND approach, some questions will favor OR approach. So let's first do it with the AND approach. So if you see, we are supposed to go from city A to C. That means the journey would be from city A to B and from city B to C. And because no road has been mentioned, so you are going to consider all the possibilities. So A to B, you have four possibilities H, I, J, K, whichever road you can choose. And from city B to C, you have just three possibilities, which is P, Q, R. You can utilize the roads P, Q, R. And because there is AND in between, you are going to multiply everything. So 4 into 3 gives you the answer as 12. So the answer to the first question is 12. Number of ways of going from A to C. And this we solved with the help of the AND approach. If we are going to solve this with the help of the OR approach, how it differs, you will get the same answer, but the process is slightly different. So it's like from city A to B, we are just going to use road H, and whenever they specify any particular road, you are only and only going to use that and nothing else as such. So city A to B, only road H, which is just one possibility. But once you arrive at B, there is no restriction. From B to C, you can utilize all three of PQR. So 1 into 3, hence from H going from C to A to C, there are three possibilities. Similarly from I is between A and B. Again, you are just gonna use that one road because they have specified that way. So A to B is just one possibility, and B to C, all three are open again. So again from I going from A to C, you have three possibilities. Similarly, I hope you would understand that for J also there will be three more possibilities, and for K as well there will be three more additional possibilities. And because in between there is a OR, you are going to add everything, and when you add everything, what you get is 3 plus 3 plus 3 plus 3, the same answer that we got earlier, which is 12. So if you realize this particular example, what we can generalize from this is that whenever the word AND is used, you are going to multiply, and whenever the word OR is used, you are going to add the cases. That is like the fundamental rule that you are going to use throughout this entire topic of permutation combination. Then the next part is next few questions. Number of ways of going from C to A to D, all possibilities A to D. So A to B and B to C and C to D. A to B as usual, four possibilities H, I, J, K. B to C, three possibilities P, Q, R. And C to D, five possibilities V, W, X, Y, Z. And because there is an AND in between, you are going to multiply everything. So 4 into 3 into 5 gives you 60 total ways from going from A to D. All possible ways basically. Then the second part of the topic is basically linear arrangement. Very simple question. 8 boys are supposed to be seated on 8 chairs. Find the number of ways in which they can be seated. So the simple rule that you are going to remember here is that in linear arrangement, n entities are arranged in n factorial ways. In linear arrangement, n entities are arranged in n factorial ways. So because there are 8 boys, so they will be all possible arrangements for all of them will be 8 factorial. But we'll prove that So suppose whichever the first boy that comes up, he can have any one of the 8 possibilities as the option to sit at the place. So suppose he sits here, A sits here, he had all 8 possibilities, he sits here. Whoever comes second will be choosing one out of the remaining 7. So the next person coming up will have 7 choices, and suppose the girl sits there. The next person comes as 6 choices, the next person comes as 5 choices, and so on. You realize that each time one option gets reduced for the next person. So whoever comes last will actually have to sit at whatever is the remaining last one place. So he will not have any choice as such. He or she will have to just sit at the one remaining place. So in short, if I ask you how many choices all of them together have, so we are going to multiply everything, and you know that 8 into 7 into 6 into 5 and so on till 1 is in a way called as 8 factorial, and that is why the rule comes into the play. In linear arrangement, n entities can be arranged in n factorial ways. Simple as that is what you can remember. The next part, few more introduction. N factorial can be written as n into n minus 1 into n minus 2 into n minus 3 so on till 1. Now excluding n, what we have is n minus 1 into n minus 2 into n minus 3 so on till 1, which can be further called as n minus 1 factorial. Then 0 factorial is 1. For this you are going to remember one simple statement, because this will have immense application in the future topics, which is not selecting anything is also one way of selection. Not selecting anything is also one way of selection, and hence 0 factorial is 1. Now what we have is one very interesting question where we are going to form a 5-digit number with the given available digits to us. So the first observation that you are going to make here is whether the examiner is talking about repetition or not. If nothing is mentioned about the repetition, you are going to assume that the repetition is allowed. So if repetition is not allowed, examiner is going to explicitly mention about that the repetition is not allowed, and then you are going to tackle that case separately. We will come about that in very short time, but right now for us it is an easy case where repetition is allowed. That means nothing is mentioned and hence repetition is allowed. Now the question is how many 5-digit odd numbers you can form. So the first thing that you need to do is define the each place, that is units place, tens place, hundreds place, so on till 10,000s place, because it's a 5-digit number. And these are the digits that are available to you, 7 digits that are available to you, and using them you are going to form a odd numbers. So odd number ka criteria, units place should have a odd digit. So from the given available digits, only 5 and 7 can come at the units place. So basically units place has 2 choices. Now when you talk about the 10,000s place, obviously there is an unsaid advantage that 0 cannot come there, because if 0 comes there, then the number will not be a 5-digit number, it will be a 4-digit number, and that is why 0 cannot come at the 10,000s place. So ideally repetition is allowed, so except 0, remaining 6 digits can come at the 10,000s place, and after that rest everywhere except 10,000s place and units place, with all those restrictions being satisfied, whether it is thousands place or hundreds place or tens place, all the 7 digits can come there because repetition is allowed. All the 7 digits can come there because repetition is allowed. And now considering all of this, all you have to do is multiply everything. When you multiply, you get the answer as 2116. So using the given 7 digits, if we were supposed to form a 5-digit odd numbers so that repetition is allowed, there are 4116 numbers that you can form, and this is how you are going to solve all these kinds of questions. Second question is how many even numbers can be formed, I think, and repetition is not allowed. So repetition is not allowed, even numbers without repetition. So examiner has explicitly mentioned about repetition not allowed. So that is where it gets tricky. And the first thing that you are going to look for is, whenever repetition is not allowed, is that whether any of the digits have a dual restriction or not. Because if the digits have a dual restriction, then we are going to take their cases separately, and that is what the note is all about. So first things, even numbers, units place will have a even digit, which can be 2, 4, 6, 8 or 0, any one of them. And we also know there is a unsaid advantage on the 10,000s place that 0 cannot come there, because otherwise number will be a 4-digit number. So considering these two things, you clearly realize that the 0 is the digit which has a dual restriction. And that is what you are also going to realize here. So the note says, whenever without repetition wale question mein, there is something called as dual restriction on any particular digit or digits, you are going to take their cases separately. So here clearly we understand that 0 has a dual restriction, so we are going to take the cases separately. So one case we will take is with 0 and one case without 0, as you all can clearly see. And now we should start working. So the first scenario with 0, units place only 0, that is one possibility. One digit goes off out of the 7 digits. 10,000s place, all 6 digits can come because 0 is anyways utilized in the units place. Then any one of the digit is used. That means again we are left with 5 digits, and every time one digit will be reduced because repetition is not allowed. So thousands place will have 5 digits, 5 possibilities. Hundreds place will have 4 possibilities, and tens place will have 3 possibilities. As usual, you are going to multiply everything. 6 into 5 into 4 into 3 into 1, which is 360. The second case, without 0, units place you have 2, 4, 6, 8, one of them, that means 4 possibilities. Out of the 7 digits, you have utilized one digit at the units place, which is unfortunately not a 0, and this is where you need to be careful. So out of 7 digits, we have utilized one digit which is not 0. That means we are left with 6 digit, and in those 6 digit 0 is present, and 10,000s place 0 cannot come. So even though we have 6 digits, 10,000s place will have only 5 choices because 0 cannot come there. Very important, very critical. You'll have to be very careful, otherwise you will make a small error here and your entire answer goes for a toss. So be very careful while doing all these things. Now again, coming back to the original data, 7 digits we had, we utilized one at units place, we utilized one at 10,000s place, and now we are left with 5 digits, and those 5 can come at the thousands place because now 0 can come there. People miss out on this, they say 4 possibilities for thousands place, but they don't realize that 0 can come there. So again, 5 possibilities only. So overall out of 7 digits we have utilized 3, that means we are left with 4. Any one of them can come at the hundreds place, and then any one of the 3 can come at the tens place. Again you are going to multiply everything, 5 into 5 into 4 into 3 into 4, which gives you the answer as 1200. Either first or second, or means addition. 360 plus 1200, the final answer to this question is 1560. So there are 1560 even numbers that you can form using the given 7 digits, 5 digit even numbers using the given 7 digits, provided repetition is not allowed. So whenever repetition is not allowed, your first job is going to figure out the digits, if there are any, which has a dual restriction, and whichever has a dual restriction, the note says take their cases separately so that you won't be confused and you will not be counting the overlapping wale conditions. So this is how you are going to solve all such questions, and this is a very unique and a easy way to do that.
Let's start with the first set. Now this is the diagram given to us, and based on this information, there are 4 questions that we have to solve. First question says find the number of ways of going from A to D via Q. Second says find the number of ways of going from A to D if root J and root X are not available. Now we have to go from A to B. So number of ways of going from A to D would be from A to B first, and B to C, and then C to D. From A to B, there are 4 ways. From B to C, there are 3. From C to D, there are 5. So total of 4 into 3 into 5, that's 60 ways. So there are total 60 ways. Now, the question says number of ways of going from A to D via only Q. So this means we just have to use Q to go from B to C. So A to B, there would be 4. from B to C only 1, and from C to D 5. So 4 into 1 into 5, that's 20. So 20 is the answer to the first question. Second question said, number of ways of going from A to D if root J and root X are not available. That means we have to skip the routes which are not available. So from A to B, there are only three ways. From C to D, there are only four ways. And from B to C, there are normal three ways. So 3 into 3 into 4, that's 36. 36 ways is the answer. Third question says, find number of ways of going from A to D through only one of K and R. Through only one of K and R means we just have to use only one route out of K and R. So there would be two things, two possibilities, from K but not R, from R but not K, by applying the same logic. So from K, that means we are just using one route to go from A to B, but not R, that means we are using two routes to go from B to C, and C to D, there are five. So 1 into 2 into 5, that's 10. From R but not K, so not K, that means A to B, there are three, B to C, there is one, C to D, there is five. That's 15. Total of this 10 plus 15, as there's OR, so it is going to be 25 ways. Find the number of ways of going from A to D such that if K is used, then R is not used, and vice versa. Now, over here, it says K is used, then R is not used. But over here, there's no compulsion to make use of one route. So, the question will be same as the previous one, but there's just one addition to it. The addition part is we will not use both the routes. That is neither K nor R. So neither K nor R will also be counted over here. So that would be 3 into 2 into 5. That's 30. So 25 plus 30, that's 55. Understand one thing. Previously it was we have to use one out of K and R. That means it's a compulsion of using one out of K and R. Over here there is no as such compulsion. If there is no compulsion, that means we have to consider the remaining possibility, that is the possibility of not using both K and R. Moving to the next question. 5-digit numbers have to be formed out of digits 0, 2, 4, 5, 6, 7, 8. How many numbers will be divisible by 20? Now there are 7 digits that we have. So first, we need to find out the divisibility test of 20. Now if you observe, there must be only one digit at the units place, that is 0. And digits at the tens place must be even digits. So units 0 and tens 2, 4, 6, 8, 0. Now, how many possibilities if there's 0 at the unit place? Only one possibility. For tens, we have 5. For hundreds, there is no restriction, so we can put all 7 digits. Thousands, there's no restriction, we can put all 7 digits. At 10,000's place, 0 can't come, hence we can put the other digits, that is 2, 4, 5, 6, 7, 8. So 6 possibilities. So 6 into 7 into 5 into 1, that's 1470 is the answer. Moving to the next question. 5-digit numbers have to be formed out of digits 0, 2, 4, 5, 6, 7, 8. How many even numbers? More than 40,000 can be formed. Repetition of digits is not allowed. In the previous question, nothing was mentioned about the repetition. Hence, we assumed it that the digits can be repeated. In the sixth question, they specifically said that the repetition is not allowed. Now, the numbers, even numbers, more than 40,000 can be formed. This is what we have to find. Even numbers more than 40,000 without repetition. Repetition without repetition means unit digit must be 0, 2, 4, 6, 8 because we need even numbers. So for a number to be even, we have to focus on the unit place. The unit place must be even digits only. For 10,000s, we have these five possibilities, that is 4, 5, 6, 7, 8. Now there's a note over here. If in without repetition, any digit has dual restriction, take the cases separately. So over here, we have some digits with with dual restriction. This means they're also coming at the units place and also coming at the tens place. That means they are of dual restriction. So we'll take the case separately. So 4, 6, and 8. These are the three digits which are coming at both the places. Hence, we can say that they are repeated twice. Basically, it's a dual restriction question. So let's take their case separately and 0, 2's case separately. This is the only difference in repetition allowed and repetition not allowed. You just have to take the dual restriction cases separately. If you figure this out, then you can definitely get the question. Now, we will solve it as we do it according to the concept. So, at units place, only three digits can come. Also, one digit would be fixed now because repetition is not allowed. So, 4 is gone. At tens, thousands place, only four digits can come. So, 5 is gone. Now, out of the seven digits, two digits are already eliminated. So, at thousands place, five digits can come. At hundreds place, four digits can come. At tens place, three digits can come. And that's it. Now, after multiplying them, we'll get 720 as the answer. Moving to the next possibility. At units place, in the second possibility, only two digits could come. So one digit is fixed. Tens, thousands place, five digits could come. One digit is again fixed. So out of seven, two digits are eliminated. At thousands place, five digits, hundreds, four, and tens, three. The product is 600. So 720 plus 600 will give us 1320, that is 1300 and 20. So option 2 is the answer. Moving to the next question. Five-digit numbers have to be formed out of 0, 2, 4, 5, 6, 7, 8. How many numbers will be divisible by 4 if every digit can be used only once? Divisibility of 4 says we just have to check the last two digits of the number. So let us take these two digits together. Now these are the possibilities of numbers having divisible by 4. Now 0 can't come at the thousands place. If without repetition any digit has dual restriction, take the cases separately. So there are two restrictions over here. 0 can't come at the thousands place and 0, 4, 0, 8, 0, 2, 0, 4, 0, 6, 0, 8, 0 can come at the last place. Hence it's a dual restriction. We will take the cases of all the 0 parts separately. Now let's put in the values. So in the first possibility, six possibilities can come. Two digits are gone because tens and units, these are the two digits. These two digits are fixed now. At tens, thousands place, five digits can come. Thousands place, four digits can come. Hundreds place, three digits can come. The product of this is 360. Now, in the second possibility, there can be only 10 possibilities with two digits fixed already. At tens, thousands place, four digits can come because zero can't come over here. So out of seven, two digits are already fixed, and one zero which can't be considered. Hence, four digits are left. Thousands place, we can consider zero. Hence, again, four possibilities would come because in this case we can now consider zero. At hundreds place, three possibilities. Product is 480. 360 plus 480 is 840. Answer is option 4, that is 840. Moving to the next question. 8 boys A to H have to be seated on 8 chairs. Find the number of ways in which they can be seated such that D always takes the corner seat. Now D, we know the specific position of. So what we'll do is we'll make D's position fixed at the corner. If we fix D, that means we just have to arrange the remaining 7 children. So 7 children can be arranged in 7 factorial way. Also, D can sit interchangeably, that is on the leftmost corner and also on the rightmost corner. Hence, there are two ways of D sitting, so it will be 7 factorial into 2. Option 4 is the final answer. 7 factorial plus 7 factorial or 7 factorial into 2. It's one and the same. Moving to the next question. 8 boys A to H have to be seated on 8 chairs. Find the number of ways in which they can be seated, such that C and D are always together. Now, C and D are always together. That means we have to assume them as one entity. So if C and D is one entity, there are total of 7 entities, one group and 6 individuals. So we have to make arrangement of 7 entities now. 7 people, 7 children can be arranged in 7 factorial ways. C and D can also sit interchangeably, hence they can sit in 2 ways. So 7 factorial into 2 is the final answer, which is option 3. Moving to the next question. How many numbers of 5 different digits can be formed using the digits 0, 1, 2, 3, 4, 5, 6, such that they are less than 45,000? Now the numbers must be less than 45,000. So it's a 5-digit number, number less than 45,000. So the only digits which we can take at tens thousands place are 1, 2, and 3. We can also take 4, but when we take 4, we have to focus on thousands place also, because the thousands place digit must be less than 5. So we can only take 0, 1, 2, 3 at the thousands place. So to find out the number of possibilities, now tens thousands, hence 3 possibilities. Now one digit is fixed already. Thousands place will take 6. Another digit is fixed. Hundreds will take 5. Tens will take 4. And units lastly will take 3. The product is 1080. In the second possibility, only one possibility at the tens thousands place. At thousands place, only 4 possibilities. Now 2 digits are fixed already. And we are left with 5 digits now out of 7. So hundreds place will take 5 digits. Tens place will take 4. Units place will take 3. The product is 240. The addition of these two values is 1320. So 1320 is the answer, which is option 1. Thank you.